Almost 50 years ago, scientists discovered a supermassive black hole at the center of our galaxy. It's called Sagittarius A star, and it spends most of its days doing nothing or occasionally absorbing gas or dust. It's located more than 25,000 light years from Earth. Even though it's a hole, it weighs a lot. Its mass is 4.6 million times larger than our sun. Well, now a team of physicists have discovered that it's spinning so quickly that it's altering the fabric of space-time around it. But this isn't the only recent space discovery. Scientists also discovered a rare six-planet star system, and they move in sync with one another. The six planets orbit a star about 100 light years away and move in an orbital waltz that repeats so precisely it can be set to music. Both of these incredible discoveries can help scientists understand more about our galaxy and space as a whole. Joining us now is astrophysicist, NASA advisor, and author of How to Die in Space, A Journey Through Dangerous Astrophysical Phenomena, Dr. Paul Sutter. All right, we're so glad to have you here to talk about all of this and just spend a minute nerding out on space. I want to ask you first about the black hole, because the whole idea of it, the fact that you had Albert Einstein opening the door to this more than a century ago with his general relativity theory, and even then it was like, that's a crazy thing. Then you get photos of it, we realize it exists. This idea of it spinning so fast, it's hard to wrap your mind around that. Explain to people what we mean when we're saying this is spinning rapidly and why it matters.
Right, so black holes, despite their fearsome reputation, are actually very simple creatures. It only takes 3 numbers to describe any black hole in the universe. You just need to know its mass, its electric charge, and its spin. And with this black hole, Sagittarius A star, we already know its mass and its electric charge, and now finally we've measured its spin. This completely characterizes this entire black hole. This is all we can ever know about this object.
So what do we mean when we're saying space-time, altering space-time? I think you just immediately go to a sci-fi movie, but what does that mean to you, and why should the average person be like, okay, we want to know this?
Oh, well, space-time is the stage. You, me, people, planets, particles, we're the actors. We hit our marks when we say our lines, and we're embedded in this fabric created by the unification of space and time into a common whole. And so when we say something like this black hole is dragging space-time around it, what we mean is that if you were to approach this black hole, if you were to fall towards it, and you were to let go, no rockets, no propulsion, just freely fall, then reality itself would be dragging around this black hole, and it would take you with it, and it would force you into an orbit around the black hole, whether you liked it or not.
So when scientists are learning things like this and are trying to apply it to big picture items, be it how we live as just this society on Earth versus just a much more galaxy view and talking about other galaxies on and on, what is the thing that when scientists find these discoveries, they say, okay, this is huge moving forward? Because this seems like it really is monumental. Is it fair to describe it as that?
This is a major discovery because we don't understand large parts of the story of the evolution of our universe. We have a lot of the big picture, but we're missing a lot of the details, and we're especially missing the details about how galaxies grow and evolve, how these giant black holes grow and evolve, how they connect to each other, and how that impacts things like the rate of star formation, the appearance of stars like our sun and planets like the Earth. And these black holes, these giant ones, they're not very common. This is the closest one to us. Yeah, it's 26,000 light years away, but that's really close in astronomical terms. This is in our backyard. This is our opportunity to study one of these monsters up close and personal and try to understand how it connects to the larger tapestry, the larger story of how galaxies and solar systems come about in our universe.
So cool. Dr. Sutter, thank you for being here. We appreciate it. We hope you will come back soon.
Thank you.